Okay, I just wanted to walk through an example of hypothesis testing. Some are a little confused with some of it, so I thought it might be best to walk through an example. So let's talk about this example. A quality control engineer works at a cereal company, and her job is to confirm that the true mean fill weight of the population of the cereal boxes filled on a given day is, so let me grab that. Give me just a second. Is 12 ounces. So the cereal box is supposed to have 12 ounces in it, and that's given. And remember, that symbol is mu, and that is the population mean, the mean of the population. Okay, so mark that in your problem as you go. If the company puts more than 12 ounces of cereal in the box, then you're going to lose money because you overfilled the boxes. Alternatively, if the company doesn't fill a box with at least 12 ounces of cereal, then the customers are going to be upset and discontinue buying the cereal, and they'd be lying to say it was a 12-ounce box. So we're talking about 12 ounces, okay? 12 ounces is our population mean. First and foremost, the quality engineer wants to ensure, now this is an important sentence, this is what's telling us what's what. Quality engineer wants to ensure boxes are not underfilled. So she doesn't want them underfilled. So that means greater than or equal to 12 ounces. Everybody okay with that? Because they're not underfilled. Underfilled would be less than 12 ounces. So you're going to pick out a sentence in the problems that lets you kind of know what you're looking for. So that is why it says not underfilled. Underfilled would be less than 12. So at least filled or overfilled would be greater than or equal to 12 ounces. So you just want to pick that out every time in your problem, because that's what my whole problem is going to be about. And then again, pick out your population mean. And then the other thing you need to look for, and this was the same in our intervals, is you want to know if you know the population standard deviation or not. So they did pull out a random sample of 100 boxes to check. So in our sample, the number of things in our sample is 100 boxes. And we do know the population standard deviation, and that is sigma equals 0.1 ounce. And remember, that shows how far our stuff in our population varies from our mean. All right. We know one other thing over here. And we are told, remember, this is a run of our regular alphabet. So this means that is something to do with the sample. And that is the sample mean is given, or the sample average. The average of our 100 boxes comes out to be 11.975. Okay, so that is stuff that is given to us, and we want to find out, we're going to do a hypothesis test to decide what the answer to our question is, and really what we're asking here is the quality engineer is trying to ensure the boxes are not underfilled. So the quality engineer, again, is trying to ensure that the boxes aren't underfilled. Okay, then the first question, if you'll answer these questions every time after you read the problem, then I think that will help you tremendously. What is the population standard deviation? I'll use the symbols each time since we're still kind of getting used to the symbols. The population symbol is sigma equals 0.1 ounces. And that means, okay, so if you're given the population standard deviation, you do a z-test. If you are not given the population standard deviation, then you would do a t-test. So that's the only difference between a z-test and a t-test. So I'll write that here. That's given, because we're given the population standard deviation. If you're not given the population standard deviation, again, you're just going to run a t-test on it. What is the average of the population, or the population mean? And we've been told that the population mean is 12 ounces, and that is this symbol. And I got that right up here. There's your right up here where I've marked population mean. What is the sample size? They told us in our sample that we were going to sample 100 boxes. And what is the sample mean? They gave that to us. That's X bar equals 11.975. What is the sample standard deviation? We don't have the sample standard deviation, so we're just going to say that we don't know it, okay? Because in a different test you might know it. It's not given. What is the confidence level to use in this problem? Just like the intervals that we did in the last section, you have to have a confidence level. And if we read through this, it does not tell us. So anytime you're not told the confidence level on any type of confidence interval or test, then you automatically use 95% confidence. Okay, so that's kind of the default. It would tell you if you were to use 90% or 99% or other popular ones. But if you're not told, you automatically use 95%. And then what is your null hypothesis and what is your alternate hypothesis? So what I want you to do every time is write this down. That is, your null hypothesis has the little 0 here for none or null. And you're always going to put, you're always going to be checking your population mean against, your population mean against what they've told us the population mean is, and that's 12 ounces. So what I want you to do is write that down. So every time you can go write HO, HA, put your colons, put your whatever you answered up here for your population mean down, put that down, and then we want to decide what symbols go where. So you're going to have less than or greater than or less than or equal to and greater than or equal to, or you can have equal and not equal to. Okay, so let me show you. I'm just going to tell you real quickly what's the easiest way to do that. And the easiest way to do it is always think that your HO always has the equal sign, okay? HO, or the top one, always gets the equal sign. And then go look at that sentence we talked about. And that sentence we talked about here was the whole thing, or what they're asking for. And it says, first and foremost, the quality engineer wants to ensure that they are not underfilled. And we already talked about that that's greater than or equal to 12 ounces. So since it has the equal to part, we're going to put greater than or equal to. And that's what we're looking for. And then the alternate is always going to be the opposite of greater than or equal to. So the opposite of greater than would be less than, the greater, but this one's always going to have an equal to part, and the opposite of greater than or equal to is less than. Okay, so again, that's going to be based on the question that I talked about above, is what kind are we looking for, or what are we trying to test? And we are testing to ensure that the boxes are not underfilled, which means they're greater than or equal to 12 ounces. And whichever one of them's always going to have an equal sign. Whichever one has the equal sign, you put it on top and put the opposite below it. Okay, now we are going to run Minitab. So I'm going to pull open Minitab. All right, hopefully you have these numbers in front of you, and I kind of don't, so I might have to go back and forth. So I am going to open up my Minitab, and that's at app.minitab.com. And let's see if I can do it with the problem still sitting here, and I'll run through one for you. So if you can answer all those questions and you can put it in Minitab, you're good to go. Usually the only problem students have is determining what I'm talking about right here on number 7, and that is which one to make your null hypothesis and which one to make your alternate hypothesis. Okay, so it's going to be stat, basic stats, and go back up to number 1. Since we were given the population standard deviation, we're running a z-test, not a t-test. So that's the only difference between these two. So we're running a one sample z-test because we have the population standard deviation given. So click on that. Once you clicked on that, we want to choose something on this first tab. And this first tab's really just saying, is all your information in a column, or do you have all the statistics given in the problem? And we have all the summarized data or all the statistics given in the column in our problem. We don't have one column of the 100 different boxes weights. Okay, then it's going to ask us what is our sample size. Remember, it was 100 boxes in our sample. Our sample mean is 11.975. That was given. The known standard deviation was given, 0.1 ounces. Okay, and don't mark the hypothesis. We are doing a hypothesis test, so you mark that. And our hypothesized mean was also given to us, and remember that was the 12 ounces. Let me make sure we're seeing everything on this page for you. Okay, and then I'm going to click on options. So make sure you see where everything came from. It's summarized data because our stuff's not in a column. That's if we had all 100 boxes and their ounces written there. Our sample size 100. So there we go through all that again. The hypothesized mean was what you were given. And click on options. Again, leave it at 95% confidence level unless it tells you otherwise. And look right here, it says alternative hypothesis. So go back to what you wrote and pick the alternative one, which is the bottom one. So you're always going to put this bottom one there, and it is less than. And click OK, and click OK, and we get our information. So hopefully you know what to do with this information. Now let's read it off. Okay, so we ran Minitab, and we were given, in this one, we were just given the statistics or the data. We were given the data. Statistics, I'm sorry. In other words, we were given all the information. We didn't have it in a column. What is your z-value? Or it may say right here, in case it just says, what is your test? I forget what it calls it in some of your test statistic. Okay, so if it asks for your test statistic, that's the same thing as the z-value or the t-value in a t-test. So our test statistic for this problem comes right off of Minitab, negative 2.50. So if you're asked for the test statistic, sometimes that's confusing to students, but the test statistic's the same as the z-value that Minitab gives you. What is your p-value? And there's our p-value, 0.006. So you just read that straight off of Minitab. Compare your p-value. This is how students, I try to get students to remember how to write this. I tell them, people eat fish out of the river Nile. And what that means is, in statistics, if your p-value is less than or equal to your significance level, then you're going to reject the null hypothesis. And let me show you something there. When your confidence level is 95%, that's 5% left to make 100%. So that's called your 0.05 significance level. Okay, and then I'll talk about that again in a second when I have more room. But if it was 99%, then your significance level is 0.01. And if it's 90%, your significance level will be 0.10. Okay, so the significance level matches up with confidence levels. That's called your significance. Okay, and then, so people, let's plug in our numbers. The p-value is 0.006, less than or equal to, and I just told you if it's 95%, then that matches the significance of 0.05. If the p-value is less than or equal to our level of significance, then we will reject the null. Which is the HO, remember? Okay, so what I want you to do is make both of your decimals the same number of digits, and then you can just compare them and ignore the decimal. So this is really saying, is 6 less than or equal to 50? And it is. 6 is less, that means that 0.006 is less than or equal to 0.050, but we can, once we make 3 digits behind the decimal, then we can just say 6 less than or equal to 50. It is. So we're going to reject the null hypothesis. So we reject the null hypothesis. So our answer is based on